Hello again, guys. Today we'll discuss this issue with animations a little bit more, especially as related to something that is quite useful for us in the sciences, which is describing the behavior of a given quantity when one of the variables involved is time. So, here's the basic idea. Imagine that you have an object moving with acceleration. And if you have an object moving with acceleration, the basic point is that its position is going to change according to a quadratic formula, which is usually given as 1/2 of its acceleration times the time squared plus the initial velocity times the time plus its initial position. So let's say, for example, that your initial position was 2 meters and your initial velocity was 4 meters per second and your acceleration, which is assumed to be constant, is 3 meters per second squared times 3 times x squared. So there you go. Your basic description of the function is a parabola, but that doesn't really tell you anything, because you want to be more descriptive of what's going on in this parabola. You want to be able to say, okay, where does this guy start? If your x-axis is time in seconds, and your y-axis is position in meters, and let's make this a projector mode, you want to be able to tell in the first place that there is no such thing as negative time. And so the way to do that is by restricting this function so that nothing is less than 0 ever. So 0 is less than or equal to x. Automatically that gives you this part only. You can look at it a little bit nicer like this. And then the second part is a little more difficult, because you want to know what happens when this thing goes forward in time. In order to do that, we are going to establish once again a parameter. Let's call it p this time, and we're gonna say that p starts at 0 and goes up to, let's say, 10 seconds in steps of 0.1. Now, how do you use that parameter in this case? You use it by restricting the domain of the function between 0 and p. And if you do that, well, it's pretty obvious that as p goes forward, then the function will extend itself. Let's make this thing move, and let's let it make it slower. And so you can see that the increasing value of the function is a little more noticeable, visually speaking, because you're making the function extend itself as time goes by. can even tell approximately where it reaches at the end of time, and you can play around with this thing a little bit more. Say, for example, that you have an oscillating value. The most common oscillating function ever is the sine function. So let's add that, a sine function of x, and we'll close it over here and see what happens when you let the time increase. And so that's another kind of animation that might be useful whenever you want to study the behavior of a function, how to make the function go forward as the parameter goes by. Okay, and that's it for tonight. See you